a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system.
In October 2025, an interstellar object 3I Atlas swept past Mars, just as NASA went silent during a government shutdown. Before the blackout, a handful of citizen scientists managed to capture and download the first images from Mars orbiters. What they found could reshape how we see visitors from beyond our solar system. Let's find out what they discovered. The cosmic coincidence. Space rarely aligns events with such precision. As of October 4th, 2025, the interstellar object 3I Atlas was drifting away from its closest point to Mars, still close enough to matter. Just a day earlier, on October 3rd, it had made its historic approach to the planet. From Earth, though, it was almost invisible. The sun's glare dominated that region of the sky, blinding even the most advanced ground-based telescopes. For astronomers, the only vantage points left belong to the spacecraft orbiting and roaming Mars. Those robotic eyes, Mars Express, ExoMars Trace Gas Orbiter, and even the Perseverance rover became humanity's link to this mysterious traveler. Their instruments captured faint light curves, subtle gas emissions, and thermal readings that hinted at the object's composition and activity. It was the first tangible evidence that 3I Atlas was not a quiet drifter, but an active body reacting to sunlight in unusual ways. Each spacecraft played its part. Mars Express tracked fluctuations in reflected light, Trace Gas Orbiter gathered spectral data from its coma, and Perseverance's long-exposure cameras recorded the surrounding sky for changes. Together, these missions formed a coordinated watchtower, a planetary network, silently documenting a visitor from another star. Then, just as the data streams began to grow promising, something unexpected happened. NASA's websites and public feeds went offline. A U.S. government shutdown had taken effect, freezing updates, halting live telemetry releases, and delaying routine communication between departments. It could hardly have come at a worse time. The world's scientists, already working without sleep to follow this fast-moving object, suddenly lost access to NASA's public databases, the same ones that routinely hosted Mars orbiter images. Within hours, dashboards that had always been open returned error messages. To many, the coincidence felt unsettling. Shutting down open data during an interstellar flyby invited speculation. Was this simply bureaucratic timing, or a barrier that might cost science its most valuable observations? As the blackout deepened, other agencies stepped forward. The European Space Agency, joined by research centers in China, India, and the United Arab Emirates, began cross-checking orbital data to ensure continuous monitoring. Their early reports confirmed that 3I Atlas remained intact. No fragmentation, no erratic changes in brightness, but its steady glow and unusual halo still defied easy explanation. Moving at roughly 37 miles per second, wrapped in a diffuse envelope of ionized dust, the object kept its course with unnerving precision. And while NASA's official channels stayed dark, independent analysts and amateur astronomers were already finding new ways to keep the story alive. Because this moment wasn't meant to disappear into silence. It was only the beginning. The discovery NASA never announced. Before NASA went silent, someone else was already watching. While official data streams were still online, a quiet discovery was made, one that would later become the first independent glimpse of 3I Atlas from Mars itself. As one citizen scientist claimed, a faint, consistent streak appeared in the Perseverance rover's sky images on October 2, 2025, possibly the first visual trace of 3I Atlas captured from the Martian surface. The angle of that streak didn't match the motion of the background stars. It wasn't dust, it wasn't a glitch, and it wasn't a satellite reflection. When compared across frames, the same diagonal path reappeared, steady, deliberate, and moving faster than anything expected in Mars' thin atmosphere. The claim quickly drew attention. Amateur observers, research students, and professional astronomers cross-checked the coordinates against orbital predictions released by the Minor Planet Center, and they matched almost perfectly. If verified, the faint streak wasn't random noise. It was evidence of motion, and possibly the first photographic trace of 3I Atlas from another planet. Soon, discussion spread across astronomy forums and data networks. Teams began re-examining readings from Mars Express and the ExoMars Trace Gas Orbiter, which recorded faint light curves and traces of ionized dust surrounding a dense, fast-moving core. These independent confirmations strengthened the case. For the first time, people outside government institutions had captured an interstellar object moving through another world's sky. Then, almost as if on cue, silence. On October 4th, a government shutdown in the United States forced NASA to suspend public operations. Data streams froze, websites went dark, and ongoing telemetry from Mars missions was halted. The timing could not have been worse. Just as the object reached its closest point to Mars, a moment scientists had prepared for months, real-time access vanished. For planetary researchers, the shutdown meant losing their window to confirm what 3I Atlas truly was. To most, it seemed like bureaucratic coincidence. But to those following the object in real time, the silence felt too sharp, too perfectly timed. The world's main source of public space data had gone dark during one of the rarest interstellar encounters in history. Rather than wait, the global science community adapted. Using open access feeds from ESA, China's Tianwen-1, and the UAE's Hope Orbiter, researchers gathered whatever data remained online. Before NASA's blackout fully propagated, automated mirror servers had already cached batches of raw Mars orbiter imagery. Citizen scientists retrieved those open files directly, legally, and transparently from international archives. With limited tools, they improvised. Volunteers wrote decoding scripts and used open-source programs to reconstruct the fragmented image packets. They synchronized timestamps from Mars Express, Trace Gas Orbiter, and Perseverance, aligning them with 3I Atlas's predicted position. Gradually, blurred pixel patterns sharpened into composite images that revealed something extraordinary. The object didn't behave like a typical comet. It appeared structured and solid, wrapped in a wide halo of ionized particles that glowed faintly under ultraviolet light. Despite traveling at such a high speed, it maintained a precise, unwavering trajectory. Its movement was calm, not chaotic, steady enough to suggest an unusual density or internal cohesion. When the reconstructed images began circulating online, scientists noticed the same striking feature: a symmetrical core surrounded by a soft, evenly distributed glow. There were no visible jets or signs of fragmentation, none of the instability seen in normal comets. The data hinted at something far stronger than a body of ice and dust. Within 48 hours, independent analysts had accomplished what NASA could not during the shutdown. They captured, verified, and released the first visual record of an interstellar object from Mars. Yet their success came with a sense of loss. In the hours NASA's systems were offline, coordinated high-resolution imaging between agencies was interrupted. The best chance to study an interstellar visitor up close had slipped away, a moment that might never repeat. Still, what had been preserved was enough to rewrite how discoveries happen. In an age where institutions paused, the world kept working. While NASA's silence lingered, the public had already pieced together the truth. A massive, stable object moving through Mars's sky, its structure unbroken and its origin unknown. And one question continued to echo across scientific circles. If citizen scientists could find it in plain sight, what had NASA already seen before the blackout began? The view from Mars. When the light from Earth's telescopes was drowned by the sun, Mars became the only world with a clear view. Orbiting quietly above the red planet, a handful of spacecraft were now humanity's eyes on 3I Atlas, an interstellar visitor slipping through our solar system with calm precision. The European Space Agency's Mars Express was among the first to record the object's faint halo. Using its visual monitoring camera, the orbiter captured several frames showing a dim, expanding envelope of material surrounding a bright, compact core. Scientists studying those images noticed something strange. The light intensity didn't fluctuate the way it should if dust or ice were being ejected randomly. The brightness curve was smooth, almost too stable for a body moving through solar radiation. The ExoMars Trace Gas Orbiter took the investigation further. Designed to analyze Mars's atmosphere, its spectrometers were sensitive enough to detect emissions from gases and particles in nearby space. During the days surrounding October 3, 2025, the orbiter picked up signatures of carbon-bearing compounds and traces of metallic ions. These readings confirmed that 3I Atlas was not inert. It was actively interacting with sunlight, but its composition was unlike anything typically seen in solar system comets. Instead of distinct emission lines for water vapor, carbon dioxide, or ammonia, the signals were diffuse and mismatched. Some wavelengths hinted at heavier elements, possibly nickel-rich material, while others showed complex organic molecules in unexpected ratios. The result was an object that didn't fit cleanly into any known category. Meanwhile, cameras aboard the Perseverance rover provided an entirely different angle. Though never intended for deep space tracking, its long exposure sky frames revealed faint streaks consistent with the object's motion across Mars's horizon. Those images, later matched with orbital data from Mars Express, confirmed that the rover had, by chance, photographed an interstellar body from the surface of another planet, a first in human history. Combined, these observations painted a picture of 3I Atlas as a body that refused to behave like any ordinary comet. Its outer shell appeared to contain ionized dust capable of scattering light uniformly, producing a diffuse glow rather than a defined tail. The steady thermal readings and unchanging shape suggested an unusually cohesive structure, possibly denser than typical cometary ice. To scientists, this stability was both fascinating and frustrating. A comet this active should have shown instability or breakage under solar pressure, but it didn't. Instead, it remained silent and steady, gliding past Mars as if immune to the chaos surrounding it. For now, the orbiter's instruments could only hint at what lay beneath that luminous shell. But one fact was certain. Mars had captured a set of observations no telescope on Earth could match. And those images were about to raise far bigger questions than anyone expected. The monster's size and speed. Measuring the size of an interstellar object is never straightforward. When an object is shrouded in dust and gas, its true scale becomes a puzzle of light and physics. Yet 3I Atlas refused to stay within the limits of ordinary. From the very first readings, it was clear that this was no typical comet. As data poured in from observatories worldwide, a research team from Harvard University, led by Dr. Richard Kluda, Avi Loeb, and Peter Vesely, set out to determine exactly what they were looking at. Using information compiled from 227 observatories and tracked by the Minor Planet Center, they compared 3I Atlas's actual trajectory to the one gravity alone would predict. In most active comets, jets of escaping gas act like miniature thrusters, pushing slightly against the nucleus and causing small deviations in their orbits. Scientists call this non-gravitational acceleration. It's tiny but measurable, an expected signature of cometary behavior. In 3I Atlas's case, however, the push was almost non-existent. That meant something extraordinary. The object was so massive that even strong outgassing couldn't shift its path in any meaningful way. From that resistance, the the researchers estimated the nucleus to be roughly 3 miles across, with a total mass exceeding 30 billion tons, an almost inconceivable weight for an interstellar traveler. To put that in perspective, 3I Atlas is more than 1,000 times heavier than either of its predecessors, Oumuamua or Borisov, the only two confirmed interstellar objects before it. Such mass suggested a core made of dense material, possibly rock, metal, or something altogether unfamiliar. Its motion deepened the mystery. As it approached the Sun, 3I Atlas accelerated to nearly 42 miles per second, a speed consistent with natural gravitational dynamics, but right at the edge of what those forces could achieve alone. There were no signs of propulsion, no bursts of acceleration, no erratic changes, just a precise, unwavering trajectory. If it was natural, it was an extreme outlier. And if it wasn't, no one was prepared to say so publicly. Spectral readings added another layer of confusion. They revealed traces of nickel, but almost no iron, a pairing nearly universal in metal-bearing asteroids. This imbalance pointed to either an exotic mineral makeup or a layered surface composition never observed before. Some researchers proposed that it might be coated with reflective material capable of scattering sunlight in atypical ways, though no theory could fully account for the evidence. When internal communications resumed after the government shutdown, NASA scientists urged restraint. Extraordinary claims, they reminded the public, demanded extraordinary proof. But even amid caution, one fact stood firm. The numbers did not lie. 3I Atlas was vast, stable, and impossibly fast, a cosmic heavyweight crossing our solar system as if it belonged to no known category at all. And for many watching its journey, that realization changed everything they thought they knew about what drifts between the stars. When science started to disagree, 3I Atlas had become more than an object of study. It had become a point of division. Every new observation deepened the mystery rather than resolved it. The data were consistent, yet the interpretations split the scientific world in half. On one side were those who saw it as a natural wanderer, an unusually dense but explainable interstellar body formed under exotic conditions. On the other were those who believed something about it didn't add up. The object's steadiness, its perfect symmetry, and its refusal to behave like any known comet sparked a wave of cautious speculation. The mainstream explanation was that 3I Atlas originated in a metal-rich region around another star, where denser materials could have fused into a solid, heavy nucleus. That might explain its stability and its faint, uniform glow. Scientists from the European Space Agency and Harvard University supported this model, suggesting that 3I Atlas was likely a rare supercomet, a frozen relic of a long-extinct system, forged under extreme pressure and temperature. But a smaller, more vocal group questioned that assumption. Led by astrophysicist Dr. Avi Loeb, they pointed out that certain details, like its unwavering brightness, structural uniformity, and unexplained surface reflections, hinted at something unusual. Loeb didn't claim it was artificial, but he argued that science should at least be open to every possibility until ruled out. NASA, once operations resumed, took a cautious stance. Officials confirmed that all known data pointed to a natural origin, yet they didn't dismiss the anomalies outright. They encouraged independent analysis and, for the first time, invited global observatories to submit corroborating data to cross-check composition readings. It was a measured response, but it acknowledged the growing uncertainty. Outside official channels, curiosity turned into a movement. Online astronomy forums evolved into informal research groups, where professionals and amateurs collaborated on image processing, orbital modeling, and reflection analysis. Every frame and spectral reading from Mars Express, or the Trace Gas Orbiter, was dissected and reinterpreted. Mainstream news amplified the tension. pitting cautious science against curiosity-fueled speculation. Headlines asked whether 3I Atlas could be an alien relic or a cosmic messenger, while scientists tried to redirect attention toward verifiable evidence. Through all the noise, one thing became undeniable. 3I Atlas defied every easy label. It wasn't erratic or unstable. It traveled with quiet precision, reflecting light in ways that still lacked a clear explanation. Whether the cause was natural design or something we hadn't yet imagined, the object had forced humanity to confront its limits, not just of technology, but of understanding itself. And for the first time, astronomers weren't just asking what 3I Atlas was. They were asking why it came at all, surviving the solar storm. Space is rarely calm, and in late September 2025, the sun reminded astronomers just how volatile the cosmos can be. On September 25th, a powerful coronal mass ejection, or CME, erupted from the sun's surface, an enormous cloud of charged plasma racing outward at millions of miles per hour. Its trajectory intersected almost directly with that of 3I Atlas, placing the interstellar visitor squarely in the path of a solar storm powerful enough to disrupt satellites and scorch spacecraft electronics. The timing couldn't have been worse or better, depending on perspective. For planetary scientists, this was an unplanned experiment. A close-range solar event could reveal how the object's surface and composition reacted under extreme radiation. If 3I Atlas were made primarily of frozen gases and dust, its outer layers should have vaporized, releasing jets and reshaping its diffuse halo within hours. But when images from Mars orbiters were compared before and after the event, the results were startling. The object's appearance was nearly unchanged. The surrounding haze expanded slightly, but there were no signs of violent disruption, no fragments, no debris, no dramatic tail formation. Its core remained bright, compact, and stable, as if the storm had passed harmlessly around it. Follow-up images on September 27th and October 2nd confirmed the same story. Small variations in brightness, minor changes in the outer halo, but overall structural integrity. For a supposedly volatile object, its calm persistence under such stress was nothing short of extraordinary. This resilience raised questions that rippled across research centers. If 3I Atlas were an ordinary comet, the CME's charged particles would have triggered visible eruptions or ion tail formation. Instead, it seemed to absorb or redirect the energy, almost as though its outer shell acted as a shield. Scientists proposed several explanations. One model suggested that its surface might be coated with metal-rich dust, creating a natural armor capable of diffusing incoming radiation. Another hypothesis proposed that the cloud surrounding it contained ionized compounds that could generate a temporary electromagnetic field, reducing the impact of solar plasma. Both ideas fit portions of the data, but neither fully explained its near-perfect stability. The event deepened scientific tension. Some argued that the encounter proved 3I Atlas was denser and more cohesive than any known comet, an interstellar relic forged under immense pressure. Others saw it as evidence of new chemistry, a glimpse into materials formed beyond our stellar neighborhood. Whatever the explanation, one conclusion stood out. 3I Atlas had just endured one of the most punishing solar events possible and emerged untouched. It didn't flare, it didn't fracture, it didn't fade. It simply kept moving, steady, silent, and undisturbed, through the wake of the sun's fury. And with every mile it traveled, the universe grew just a little more mysterious, the seed of new worlds. While some scientists debated whether 3I Atlas might be artificial, others approached it from an entirely different perspective, not as a mystery to solve, but as a clue to how planets may begin. Among them was Dr. Suzanne Fner, an astrophysicist who studies how interstellar material shapes young star systems. Her idea was strikingly simple. Perhaps objects like 3I Atlas aren't accidents of cosmic travel, but seeds of creation, building blocks that help forge new worlds. For decades, the process of planet formation has carried a fundamental problem. The traditional model begins with a young star surrounded by a rotating disk of gas and dust. Over time, small grains collide and stick together, forming pebbles, then boulders, and eventually planetary embryos. But this process is painfully slow. The gas within these disks dissipates after only a few million years, far too quickly for giant planets like Jupiter or Saturn to grow to their observed sizes. Fner's model offers a potential shortcut. She proposed that interstellar objects, dense, solid bodies traveling between stars, might occasionally fall into such disks. Once captured by gravity, they could serve as ready-made planetary cores, allowing gas and dust to accumulate rapidly around them. In this way, a drifting interstellar body could transform from a wanderer into the foundation of a planet. Her simulation supported the concept. Systems with larger, more massive stars were far more likely to capture passing objects, and those same stars are statistically more likely to host gas giants. The correlation fit perfectly. Interstellar visitors, rare as they are, could be the missing catalyst that explain why some planetary systems flourish while others fade. If true, 3I Atlas isn't merely a visitor, it's a window into the same mechanism that once shaped our own solar system. Billions of years ago, a similar object may have entered the young sun's disk, seeding what became the first of the giant planets. The theory remains unproven, but it has changed how many researchers view the encounter near Mars. 3I Atlas might not be an intruder. It could be a messenger of creation, revealing how the universe recycles its own remnants. Whether born of nature or something yet unknown, it reminded us that creation and mystery often share the same path. And somewhere within its trail, the story of new worlds may already be beginning. A world watching in the dark. By early October 2025, 3I Atlas was already moving beyond Mars, drifting steadily toward the inner solar system, growing fainter but no less mysterious. NASA's silence had left a gap, but that absence was quickly filled by a collaboration no one had expected. Across continents and time zones, professional astronomers, research agencies, and citizen scientists became part of the same collective effort. The European Space Agency, China's National Space Administration, and the United Arab Emirates Space Agency coordinated their Mars orbiters to maintain continuous observation. Each spacecraft contributed a distinct layer of insight. Mars Express tracked optical brightness. Trace Gas Orbiter measured volatile compounds, and the HOPE mission monitored subtle changes in thermal radiation. Together, they began assembling a shared portrait of the traveler that Earth itself could not see. At the same time, online networks of independent researchers continued refining their analyses. Using open-source software and public databases, they reconstructed 3I Atlas's evolving trajectory and light curves with remarkable accuracy. For the first time in space science, amateurs and professionals were working in real time toward the same goal, not separated by hierarchy, but connected by data. The outcome was unprecedented, an interstellar event studied and documented by humanity as one. Governments contributed orbital tracking, universities analyzed spectra, and individuals refined digital images from mirrored repositories. When combined, their results formed the clearest view yet of a visitor from beyond the stars. The data revealed an object that defied every easy classification. 3I Atlas remained structurally stable under constant radiation, displayed spectral lines never before cataloged, and carried a mass so immense that its orbit appeared almost immune to solar drag. Even as it retreated from Mars, its form and motion stayed remarkably consistent, steady, luminous, and unyielding. Still, one question lingered. What exactly was it? A natural remnant of another system, or something that challenged that definition entirely? The JUICE mission, already en route toward the inner solar system, is expected to cross its path near perihelion later this year. Scientists hope those readings will finally uncover what makes 3I Atlas so unique. Yet even if no definitive answer comes, one truth has already emerged. When official systems went dark, curiosity took their place. In that silence, humanity found its own voice and listened together. Because even in the dark, the universe continues to speak. And this time, we were ready to hear it. If this story fascinated you, give it a like and share it with others who love uncovering the unknown. What do you believe 3I Atlas really is? A natural wanderer or something more? Drop your thoughts in the comments and subscribe for more journeys that explore the mysteries beyond our world.